Good morning, sir. Good morning, classmates. I am Genesis S. Torres from Math 2B, and I am assigned to answer number 54 on a Chapter 2, Exercises 2.2. So, let's start. So, number 54, and there is a question said that prove properties 2, 3, and 4 of theorem 2.6. And there's a statement said that if A and B are matrices with the sizes such that the given matrix operations are defined, and C is a scalar, then the following properties are true. So these are the three properties. So here at number 2, there it is A plus B transpose equals to A transpose plus B transpose. Number 3, C times A transpose is equal to C times A transpose. Number 4, A and B transpose equals to A transpose B transpose. So, let's begin to answer number 2, which is A plus B transpose equals to A transpose plus B transpose. So just write it on the bottom. So we have A plus B transpose equals to A transpose plus B transpose. So we have left hand side and right hand side. So let's start to answer left hand side. So we all know that a matrix A is equal to A I J, and B and matrix B is also equal to B I J. So A plus B transpose is equal to A I J plus B I J, and all these are transpose. And now let's apply this transpose on Aij plus Bij. So the answer is Aj plus Bji. So the next step we need to do is we need to prove the right hand side. So we all know that the matrix A is equal to Aij, and the matrix B is equal to Bij, such that if we are going to apply the transpose, so A transpose is equal to Aj and here B transpose is equal to Bji. So therefore A transpose plus B transpose is equal to Aj plus Bji. So therefore we conclude that the left-handed side and right-handed side are equal. So the next thing we need to prove is number 3, which is C times A transpose and C times A transpose. So let's just write it on the bottom. So we have number 3 C times A transpose is equal to C times A transpose. So we already know that the matrix A is just equal to A I J, and the A transpose is just equal to A J I. So the first thing we need to prove is C times A transpose. So C times A transpose. So we all know the value of A. So C times Aij. So just multiply it to Aij, because Aij will be multiplied to C, or it is the entry to multiply the C. So it answer C A J I N. So that is the final answer. So now let's prove C A transpose. So C A transpose. So we already know the value of A transpose. So this is the value of A transpose. We have AJI. So C times AJI. So it is just equal to CAJI, and that's all. Therefore we conclude that CA transpose is equal to CA transpose. And lastly, we need to prove AB transpose is equal to A transpose B transpose. So we need to write it here. Number 4, which is AB transpose is equal to A transpose B transpose. So now we need to make a conjecture about the transpose of the product of two squares matrices. Select two other square matrices to check your conjecture. So we need to let A is equal to the matrix of 1 or 1, 3, 2, 4. And the matrix B is equal to the first column is 3, 1, and second column is 5 and -1. The next thing we need to do is to prove this left hand side, which is AB transpose. So first let's write the value of matrix A, which is 1 and 3, 2 and 4, and multiply to the value of the matrix B, which is 3, 1, 5 and -1. So how to multiply these two matrices? This first row to multiply to this first column and second column. So, and second row will multiply also so to this column and this column. So let's start multiplying it. So 1 times 3 is 3, 2 times 1, so plus 2 times 1 is 2. So next is 1 times 5 is 5 plus 1, 2 times negative 1 is negative 2. So second row we have 3 times 3, we have 9 plus 4 times 1 is 4. Next, 3 times 5 is 15 plus 4 times negative 1 is negative 4. So the answer is 3 plus 2, we have 5. 5 plus negative 2 is 3. And next, 9 plus 4 is 13. So 5 ay 15 plus negative 4 is 11. So this is the answer. If we are going to apply the transpose here, so this is the answer for the A or the matrices A multiplied to the matrices B. It is equal to 5, 3, 13, and 11. If we are going to apply the transpose, it will equal to 5, 13, 3, and 11. So the next step we need to do is to find or to prove this A transpose and B transpose. So first, let us write the value of the matrix A, which is 1, 3, 2, and 4. And the matrix B is 3, 1, 5, and negative 1. So the A transpose is equal to 1 and 3, 2 and 4. So B transpose is equal to 3 and 1, 5 and negative 1. So the next thing we need to do is to multiply this A transpose to B transpose. But we need to write it first, the B transpose multiplied to A transpose, because it satisfies the answer, which is 5, 13, 3, and 11. So let's start. So the B transpose is equal to 3, 5, 1, and negative 1 multiplied to A transpose, which is 1, 3, 2, and 4. So we need to multiply it. So we need to multiply this row to this column and this row to this column also. So let's start. 3 times 1 is 3. So 1 times 2 is 2. So next is 3 times 3, we have 9 plus 1 times 4 is 4. So 5 times 1 is 5, and plus negative 1 times 2 is negative 2. So 5 times 3 is 15 plus negative 1 times 4, which is negative 4. So the answer is 3 plus 2, we have 5. 9 plus 4, we have 13. So 5 plus negative 2, we have 3. And 15 plus negative 4, we have 11. So therefore, I conclude that AB transpose is equal to A transpose plus B transpose. And that's all. Thank you.